Hi, my name is Jeff Schinella. I'm a product director at GitKraken. I'm going to talk about cycle time and throughput. We're going to go over just high level where they come from, why they're important, and the goal of this talk here is to just spark some ideas and get people thinking about adjustments and ways they can improve their development workflows to make improvements to these metrics, and the end result would be obviously improvements to the product, to the workflow, and the overall happiness of developers as they tend to, can be frustrated with things that get in the way of blocking high cycle time and get throughput numbers. So what are cycle time and throughput? There are two of the four DORA metrics. DORA stands for DevOps Research and Assessment. These were popularized with the book Accelerate in 2018. The other two are mean time to recover and change failure rate. These can be called by other names: North Star metrics, value stream analytics, and then cycle time can be called lead time for change. Throughput can be known as deployment frequency, but they all encapsulate the same thing, two main sort of principles, which is shipping code faster and with higher quality. Cycle time and throughput are the speed side of things. They are a true measurement of the pace, the frequency at which you're releasing software to your customers out into the wild. And in an ideal world, the code changes that you ship are delivering value and making your customers happier. I'll be focusing on the speed side of the coin and not so much on the stability side for the purpose of this talk, but just keep in mind those two things do exist and you do need to account for both when we're talking about being able to deliver software effectively. So really quick definition: cycle time, how long it takes for a change to be merged into production. These can be broken down into different parts: your dev time, your review time, your deployment time. I'll go into some more details there, but it's really any unit of work. It doesn't have to be a pull request, although very often people look at pull requests and cycle times as a unit of measure. But it can be on JIRA issues, maybe even on just the life cycles of branches or even commits themselves. Throughput, for example, though, is very simple. Simply put, how frequently your changes are being merged, right? The pace that they're getting in. How many pull requests are we getting in per week? How many JIRA issues are being processed a week? Whenever the work is started to when the work gets in, you're just counting those up as a tally. These don't account for complexity, so it's not really a full picture of knowing that some PRs could take a long time compared to others based on the size that they have higher review times, or even the development and coding time of a certain change that's bigger a feature, for example, compared to a small bug fix. So taken with a grain of salt, but it is helpful for understanding other metrics and counting just the frequency of things going in, like merge rate, which is what percentage of the changes that are being proposed over a certain time frame get completed. So when we're talking about the cycle time and throughput metrics, there's some opinionated definitions about what good looks like. DORA is very explicit. You want your cycle times for lead performing teams to be less than a day, right? You can start and complete a change, and that change from the throughput side just is on demand, pushed out into production. There are other personal opinions, third-party surveys, but they all correlate to the same thing. The faster you can do these things, the better off and the more efficient, the better off your development team and developer workflow looks like. My personal opinion is, who cares really? Just find your baseline, focus on getting better, not necessarily good. You might be part of an organization like a financial institution or a government agency that simply can't merge things within a day or even within a week. There's just a lot of audits and checks that have to go in before you can even begin to get code that you're working on out into a public-facing environment. So focus on getting better and making improvements based on what's right for your team, not necessarily what is published out there for elite teams. So what does it change when we're making changes? Again, a lot of these tools, a lot of content out there focuses on the pull request. I think it's a good idea that we can look at change as a whole, right? It's the planning and design, which can be sort of proof of concept. It can be conversations or like reviewing documentation, understanding how it is you want to go ahead and make that change. Then there's just the actual development and coding side of things and the implementation of the work, the unit of work that you're measuring, all up until you get to the pull request. And then even at the time that you get to the pull request, you begin the review cycle and refinement, where a lot of tooling, a lot of systems out there will give you an analysis on, where the bottlenecks happen during the review cycle. Once that PR is merged, you also have a deployment and release phase. This is, where the DevOps really comes into play. There's a lot of levers you can set up and automations you can set up to get your merged code out into production faster and deployed faster. What we're going to focus on here, though, is everything to the left of the pull request. There's a lot of content out there, a lot of tools out there that talk about the PR optimizations and things that happen after. And I'm going to just spend a little time having us think about stuff that happens before the PR. So there's a lot of room for new ideas, being creative, and just addressing, development workflows and strategic approaches to how we go ahead and make code changes in our repositories. And, why is this matter? This is pretty important. I think an underlying principle that exists is, the longer your code stays away from being merged and submerged, the more complicated your workflow is going to become. You're going to have an increased likelihood of having to deal with merge conflicts or reworking and refactor code. Most of us don't work in a bubble. There's other developers, pushing code, making changes to your repositories. And so as those changes land and your PR and your change becomes more and more behind the main trunk branch, the more likely it is you're going to have to do additional work to get that code working again as the new ideas and new functionalities introduced to your repo. It also sort of correlates to the abandonment. The longer that your PRs grow and become stale, and those changes grow, the more likely even the thing you were working on could become irrelevant. Things just get reprioritized, decisions happen at the product level, at the business level, that sort of cause the work you have done to just be irrelevant and become abandoned. And on top of that, just getting back into that productive mindset. Not only does it take you a while to remember the model, why you made the changes, how they were put together in the first place, but you might have to go and spin up older branches of dependencies in your local environment, do a bunch of rebasing on different repositories and branches that are correlated with that. So overall, not having things merged in a timely fashion leads to headaches during the review process and maintaining that code to try to get it in again later on. So asking the right questions, I think, is very helpful. The main question being obviously why? Why are pull requests taking a long time to review? Some reasons we have found, obviously, code quality might not be up to par. There might be missing some style guides or best practices not being applied. There could be tests or dependencies that need to be included that have been overlooked. Generally speaking, we've found that sometimes certain reviewers are way overloaded, or even developers who are just working on so many different projects have no time to even do 1 or 2 reviews because they're trying to get their work done. And context switching is a huge issue, right? You've started on a new change, which leads you to sort of forget or ignore changes that you worked on from a week or so ago. So asking questions about why maybe these things exist can lead to making adjustments that can improve not only our workflows and our ability to handle these changes and these issues that pop up, but improve those cycle time and throughput numbers in the long run, which is kind of, convenient. So ways we can improve. One, understand the baseline. There's going to be, you don't know if you're improving if you don't know where you started. There's a lot of third-party tooling out there to help you get your cycle time. You can Google engineering metrics or DORA metrics for your repositories and try some of these tools out there. You can do it yourself, getting some of the data from GitHub, or even I think GitLab offers some of the reporting tools there. And we for fun, spun up grader.gitkraken.com, which is just a simple single page web app. You can get a cycle time score for any repository on GitHub if you're interested. And once you have these baseline numbers, you can go ahead and use them as you start to make tweaks and adjustments. And that's pretty much it. I'm hoping that you've sort of sparked some ideas. I'm interested to hear, how your team handles and finds pull requests taking longer than expected to merge. Feel free to tweet that at GitKraken at GitKon, or reach out to me at my email address or on LinkedIn. Left some useful links on the side here for the Grader site and GitHub automations and actions that you can find to start experimenting and seeing how they work for you. Appreciate your time. Thanks for listening.